-3/7. Who else got -3/7?
Colton did.
You say a lot of us should have. I did see a lot of us.
Didn't.
Now, Aaron, walk me through how you got that. Say that part one more time. Sorry.
It was the only illusion that you gotta show how negative
Okay.
on the computer device.
So that works for this one because -21 is greater than -25. Does it work for everything else? Is it in the second quadrant? Yes. And it happened to fall on both of these lines. I saw some of us find the intersection on Desmos or the calculator and then see if everything else worked.
Yeah.
And that also worked. But -3/7 should have been our final answer. But alright, let's exit in.
So you do second plus. And then 7.
Alright, so last class we talked about how to solve a system of equations graphically. Today we're going to talk about one of the ways to do that algebraically. So everyone should have the notes that look like this in front of them. And I'm going to pull this down so you can start writing these in. So today we're talking about the substitution method, a method of solving systems of equations by substituting equations within one another.
I tell you something.
Similar, but different. For step 1, we solve an equation for x or y if it's not already solved for x or y. Step 2, we substitute the expression into the other equation and solve for the variable. Step 3, we substitute that answer we got. So after we solved, we got an answer. We're going to take that answer, put it back into one of the equations, and solve for the other variable. So it's a lot of solving, substituting, solving, substituting, solving.
We're very alive today.
If you didn't get these written down, make sure you're writing these down. See a couple pencils still moving. Anyone else still writing? So we're going to put this into practice and do just one before lunch and then do the rest when we come back. So for number 1, you have to look and see, are either of these already solved for x or y? If I look at either of these, are these solved for x or for y already? They are already. So that means we don't have to do step 1. It's already solved. Step 2, substitute into the other. For this type of problem, you have choices. You can either take this expression and put it in for the second y, or take the second expression and put it in for the first y. Doesn't really matter which one, because at the end, it's still going to look like this. Because we took one of the equations and put it into the other y, replaced it, substituted it. And then this looks like something we've seen before. So we can solve this. Get all the variables to one side, all the constants to the other. How you do that does not matter. If you want to do it the other way, that's fine also. But then we have to get x by itself by dividing both sides by 2. And that's part of it. The other part is taking this number we just found and putting it back into one of the x's of one of the equations. Does not matter which one. And we'll finish that when we get back to lunch. So guys in the back, focus. So the last thing we did was, I said we needed to put this here in Allison's way. Right here in Allison's way.
Oh my gosh.
We need to put -2 in for one of the y's. It does not matter which one. So let's say I choose the first one just because. Then we're going to solve this, figure out what y is. So multiply, and then combine.
What?
One of you is playing music loud.
Oh, no.
After you have both x and y, you would write this as an ordered pair. And that would be your final answer. I would say box in that answer so we know that's your final answer. Do we have any questions on that process? How we got that answer? Anything like that? This type of problem where you set it up equal to each other, you won't see a lot, but you will see. Most of them will be set up similar to these. So we're going to do number 3. Your first step, you should always be asking yourself, bless you, is one of these equations solved for x or y already? Yes. The first one. It doesn't matter that the second one's not. We don't need to do anything with that. So we're going to take this equation and put it into the other where y is. So it's going to look a little different than what we just did. And we're going to rewrite this second equation. So it'll look like 3x plus 8 times x plus 9 equals negative 5. From there, we're going to solve it. So distribute, start combining like terms, solve for x. We combine our like terms, we get 11x plus 72 equals negative 5. Then we can just solve for x. Subtract 72 to both sides, divide both sides by 11. So when you divide, your x would be what? -7. But again, that's only part of the work. We still have to find our y value. Questions on anything so far? So then we can take this x value and put it back into the x of our y equation to figure out what y is. And then what would be our final answer? We have to put those two together in order here.
-72.
Mm-hmm. Just like that. If you get a solution like we have been, that means if we were to graph these, they would cross somewhere here. Questions about this? Once we get the hang of it, the process isn't that bad, it's just repetitive. We are going to do 4. Do we have an equation where x or y is already solved? Yes. But this time it's x, not y. So one of the biggest things here is making sure you substitute into the correct thing. You'll know when you don't substitute into the correct thing because you'll have still 2 variables instead of just 1. So we're now going to take this expression and we're going to put it in for x, not y, because we have an x equals. And then rewrite that second equation. 2 times 4y plus 7 minus 6y equals 12. And then we can start to solve. Distribute, start combining like terms, get y by itself. So we combine our like terms, we have positive 2y. Subtract 14 and we have a negative 2. Divide both sides by 2 and y would equal a negative 1. Then, just as before, we're going to take that y value and put it back into our x equation in the original. So the arrow, you can draw it if it helps you. You don't have to do that part. So x equals 4 times negative 1 plus 7. That's what we're going to solve. Multiply to get negative 4. And add to get 3. Be careful when you go to write your answer, because we solved for y first, not x. It still needs to be xy when we write our answer. What would our answer be? 3, negative 1. Make sure that is in parentheses. Do we have any questions on that process, how we get that answer, anything like that? I just want to show you a couple more, then any others you want to see go through, we'll do that. So when you finish writing this down, go on to the next page and do 5. With these type of problems, you don't see an x or a y that's solved already. So we need to pick one of the variables and one of the equations and solve for it. The easiest one to solve for is whichever variable is by itself. So it doesn't have a number in front, or the number is 1, or it just has a negative in front, either or. So for number 5, we're going to solve for this y in the first equation because it's by itself. I'm going to rewrite it so I have more space to work. And we're going to solve this like we would if we were graphing and had to get it back in slope-intercept form. Get rid of the x term by subtracting it to the other side. Then we have an equation that's solved for y, or x, it depends. Then we can start the process of taking this, putting it in for y of the other equation. So rewriting that second equation with this in it. 5x plus 3 times negative 2x minus 2 equals negative 8. And then start to solve. Distribute 5x minus 6x minus 6. Combine your like terms and solve for x. Here we would have to divide both sides by negative 1 to get x by itself. But again, that's only part of it. We still need to get y. So you would take that number and put it back into, you have options. You can put it back into either of the original equations, or you can put it back into the one you solved. Either way, you're going to get the same answer. You should get the same answer as long as your math is correct. So if we were to solve for y, this would become y equals -4 minus 2, or -6. And then our final answer would be 2 -6. Do we have any questions about this process, about how we got the answer, anything like that so far? There is one more that I want to go over with you, and then any others you see you want to go over, we'll do that. Let's do 7. So, process will start off the same. Find a variable that's by itself, so x in the first equation. Then we're going to solve that equation for x. I'm going to rewrite so I have space to work. And then to get x by itself, we would move this over by subtracting. If you want to switch them, that's fine too. I didn't in this one. Then we're going to take that and put it into the other equation where x is. Rewriting that second equation as 3 times 4 minus 5y plus 15y equals -1. Distribute. And then combine like terms. What happens when we combine these like terms? They cancel, becomes 0. So that means all that is left is no more variables. All that's left is just the numbers. Does 12 equal -1? Is that a true statement? No. Because these are not equal, of the 3 types of solutions you can have, 1, none, infinitely many, which one would this be? No solution. So if you get a no solution or an infinitely many solution, you'll realize right away that that's what it is, because your variables will disappear. Do we have any questions about that? I will say there's at least one other that gives you either no or infinitely many. Look through the remaining problems on this page, the one we skipped over, or any practice problems on the last page. Find any you want to see, go over, have questions about, not sure where to start, anything like that. All right, 9. I'll circle all and then we'll go through them. It's okay. 11. Aaron. 4 on the last page. Any others?
Number 8
8 on which page?
on the top one.
This one? Okay. Any others? Right. 7 on which page? Okay. Alright, so let's start with 9. We have to get a variable by itself. Which variable are we going to get by itself? The y in the second equation. So let's solve that by subtracting 2x to the other side. And then, what would be our next step? We have our equation solved for y, but what do we do with that? Allison? So 6x plus 3 times negative 2x plus 18 equals 54. Start to solve. What happens here?
You combine.
Yes, and then after you do that, what happens? Brian?
The x is canceled.
Correct. So we're left with 54 equals 54. What type of solution would that be? What were you going to say? Infinitely many? Yep. And then we're going to answer the last one. So if it's one of those two, you'll know early on because you won't have any variables. Questions on 9? Okay, let's do 11. Same process. But now we have a negative y, so we're going to have like one extra step to get y by itself. So still move your x over. But what would I do here to get y completely by itself?
Combine by negative 1.
Yes, but you need to still say. Divide everything by negative 1. And then put that back into the other. Make sure you are putting it back into the other equation, not the same one, because the variables will cancel when you don't want them to, if you put it back into the same one. So then this will become 5x plus 2 times our equation, 8 plus 3x equals 5. Distribute and solve. Here, when you combine your x's, you get 11. So you have to subtract the 16. And divide. And then go back and put that in for y. and solve for y. Y equals 8 minus 3, or y equals 5. So our final answer is negative 1, 5. Questions on 11. And then when you're finished writing that one down, turn it over to the last page where we'll do 2 more, and then you'll have time to practice. Three more, and then you have time to practice. Okay, 4 and 7 are very similar. What's nice about these problems, because they are a x equals or a y equals, they're giving you part of the problem. So you don't have to solve for y because we already know what it is. We just have to find x. So we can take this and put it in for x. No, disregard what I just said. Take it and put it in for y. Is what I meant. To solve for x, there we go. When I did it, I was like, that doesn't look very good. So there will be one less set of work with those type of problems when you're given x or y. Still have to write it as an ordered pair though. Have any questions about that? The process, the answer, anything? So we're going to do 7 and then 8. Same thing. We're given our y, so we're going to put that in for y. To solve for x. So we would subtract 12 on both sides and divide both sides by 6. So then our ordered pair would be negative 6, 3. Do you have any questions on that one? For 8, it's one of the equations are solved already, so we're going to take that and put it in for the y of the second equation. And then solve for x. Combine your left terms. And solve for x. So that x equals 4. And then we just have to find our y. So take that x, put it back into your y equation where x is. Space for this. And solve for y. So then our final answer would be 4, -2. So for the remainder of class, I want you guys to practice. There are 3 different things you could be practicing. 1, the remainder of these problems in these notes. You can go through those and practice those. There is 1 Khan Academy on this that is also due next Friday, so you could be trying that, getting it out the way so you don't have to worry about it next week. And then I also have a partner activity that deals with systems of equations by graphing and substitution, so it's practicing both things, but you have to have a partner to do it with. So if you want that, just come see me and I can grab that for you. Otherwise, be working on something. Let us know if you have any